Great. And we're live. Okay, so welcome everybody. I'll just let other people in as they arrive. Welcome to this subsurface rendezvous today. And we have Jan Rivenæs with us, who's going to take us through reservoir modeling with XTGeo. For anyone who hasn't been along to one of these before, it's an open Zoom meeting, so it's not sort of a webinar. And what we do is we'll have a presentation and a demo from our host, Jan. And I guess feel free to put questions either in the chat here in Zoom or in the Slack channel if you're in the Swan Slack. And we'll just either pick up on them at the start of the discussion, or if they're timely, particularly to what Jan is going through at the time, we'll just, feel free also to raise your hand, or I'll be keeping an eye on the chats and we'll call out and stop things and read out any questions that are particularly timely. But just feel free to fire stuff away in the chat or raise your hand and we'll pick up on it. Great. Well, without anything else, I'll hand over to Jan to take us through XTGeo.
Yes, thanks a lot. Yeah, and thank you for the invitation. So my name is Jan Rivenæs, and I'm working in Equinor. So I started in the oil industry in 1991 or something. So I've been working with geomodeling and a lot of programming also. So it's been a big mix in a way. It's kind of a hybrid between a geologist and a computer scientist in a way. So I will tell you a bit about XTGeo. So I just made a small agenda here, overview and background for XTGeo, and then I will try to give some online demonstrations. I hope the technical things works. And then I'll wrap it up a bit with way forward, and we can also, if there are kind of bigger questions, we can have them in the end. So before I jump into XTGeo, I want to set it in a bit in a context, because in Equinor we have something called FMU, or Fast Model Update. And that's the kind of a modeling chain we have developed where we kind of take the input data. It could be core descriptions, logs, seismic interpretations, and so on. And then we try to chain everything into a complete loop or machinery, as demonstrated here with the reservoir modeling, flow simulation, and assisted history matching, running uncertainty, and so on. So the idea is to set up everything and then run the button, and after some hours we will get, let's say, 100 or 200 realizations of a run. So the idea is to do this automatically, and they are run in parallel on clusters. So instead of waiting for the realizations to be run sequentially, they are run at the same time. But of course, this is a kind of a complex thing. Here's a bit more concrete on what we have. So we have all the data as mentioned. And then we have this workflow manager, which is in Equinor called ERT, which is an internal development, but also open source. And we use components, mixture of scripts and vendor tools like RMS for reservoir modeling and Eclipse for flow simulation. So, but we want to kind of, in principle, be a bit tool independent, so we could replace both of these. And we actually have, in some cases, replaced Eclipse with a open source OPM flow simulator. So at least this workflow manager is the kind of the thing that runs everything, and we get multiple realizations. But of course, as I said, to make this kind of work, we need some oil or lubrication in the system, and Python has become quite important for us. So we use a lot of Python, both in the ERT system, but also into the individual components. And XTGeo is one of the libraries that we use for this, to get everything kind of running and to get things automated. As probably many of you know, many of these vendor tools, they have kind of nice interface for doing things by clicking and mouse use or interactive use. But in this case, we need something that is fully automatic. So if we, for instance, want to generate take all the maps and make an average map, we need to do it automatically by script. So a bit about XTGeo. So it was something that I started with very brief, or kind of in the small around year 2000, because I always find that vendor tools, they cannot do everything you want to do. So I wanted just to not just only making a script, but actually make a library which other people also can use, so you can reuse code. So during the first almost 15 years, I made a Perl combined C library, which can do a lot of things. But then I had to admit one day that Perl was not the correct horse, so I needed to switch, and I switched to Python, which of course took a bit time to learn all the nitty-gritty details of Python and so on, but tried to do a kind of complete redesign. So you can see many things have changed during here, but also kept most of the C library, for instance, for reading Eclipse or for doing special things. So at first we supported Python 2.7 and 3.4 and later. So this year, I think it was, or half a year ago, I skipped 2.7 support. In Equinor, we have a kind of policy saying that if libraries are not, for good reasons, to be held closed, we should actually open source them. That's kind of the default thing. So in 2019, in May, we open sourced XTGeo. So we had the first release under the LGPL version 3 license. The major building platform or development platform is the Linux platform, but I ported it now so it works also fully under Windows 64-bit and Mac OS 64-bit. So it should work on every platform. And it's the C part that has been a bit tricky there, or was, yeah. So for the user, they only see a Python interface, but in the background, there might be some calls to C through what is called SVG, which is a wrapper language to connect Python and C. But that is something the user need to know about. But if you are a developer, you need to know how it works. Another important thing for us was that the RMS, which is the main modeling tool in production, at least in Equinor, they made a transition from what they call an internal programming language, which only they supported, and they went over to Python. But their Python API is kind of quite basic. It's reading data and writing data back to the tree and so on. So there was a bit kind of missing methods if you want to do something special, say that you want to do something with a surface inside a polygon and so on. That was not kind of direct functions for that. But the main focus of XTGeo is to run it from outside any vendor tool. So this is just showing the kind of the difference. So if I want to read a well from a file, I'd say well from file, and I have the name of the file, or a surface from file. Or I can take it from Roxar, where I have to be a bit different syntax, because I need to address the way it's stored in our RMS. But if I then want to use a function, it's kind of independent if I'm in the Roxar environment or outside. And then I can write it back either to Roxar or to file. So it should work in both ways. So the way it kind of interacts with the RMS data is that it goes through the Roxar API. So for instance, the Roxar API gives NumPy access to the surfaces and grids and so on. So it's kind of just using that directly or more or less into XTGeo. So that was the kind of the overall background. So now I will jump into some demo. So I will see here. So this is, I told in the invitation I was going to use Jupyter Notebooks, but I simply think I skipped that. And I will work directly in our RMS. And that is just because in XTGeo we have a bit of plotting, but it's not a plotting tool. So if I want to show the results in graphics, it's very nice to use RMS for that. So the first thing I want to show is, for instance, how I can read a surface. So I have a surface here in the tree here. Just skip that and show the surface. Too much data here. Yeah, so here we have a surface. I just call this something. Surf.py, and then I just say I can make it bigger. Import XTGeo, and then I want to read a surface and say surface equal to XTGeo surface from Roxar. And I need this magical project, which if I run it outside RMS, it will be the path to the project. And then I need the name of the surface, which in this case is top Volantis. And then I need to have the category in this case, which is depth surface. But I can also read this from a disk, and if I already have this on a disk, I think it have it out here. Not here, sorry. Many folders. I'll find it afterwards. But I could have said something like is XTGeo file from surface from file, and then I could just have the file name, which could be something top.gui. I think this one should work actually. Now I can just execute this and see if it goes well. I spelled it wrong. So then it worked. And I can just print this instance, and that will get some information on it. So it says it's a regular surface, number of, I can enhance it, number of columns and rows and active cells, and a bit details on the mean and so on. And the next thing I can do, I can also print the rotation directly, for instance, if I want, which is 30 degrees. And I can also print the values, which is an NumPy array. And what I can do then is that I can do operation on that NumPy array. So I can say as one values, I can multiply it with 2, for instance, and then I can see what happens here. So I can just read it again, and when I multiply it with 2, it will be double, of course. And the next thing I can do now is just to write it back to file, so I can put it on some file, or I can put it back to Roxar. To Roxar project. I think I just put it in an empty category here called mantle. It's a bit strange to do that, but just for the demonstration. So now we see, if you see this gray here, it will be filled up, and if I now plot it, it will have the depth values, the double. So this is just a very simple example on how you can deal with surfaces. And of course, you can also do other operations on the surfaces. I could say something that I want the depth surface here if they are, as in do NumPy operation, if they are less than, say, 700, they should be set to 700 or something. So now they will produce this truncated map here behind. So yeah, and this is usually quite quick also to run, also for quite big surfaces and so on. The next example I can show you is a seismic cube. So I will just save this, and I will make a new one, which I call just cube.py. Same thing. Import XTGeo. And now I can call C is XTGeo cube from Oxa. This can also be from file, and if I use a file version of this, if use file version, it will use our other open software on SegY. So it will use this SegY IO library, which I think you have had presentations on before. So I started first to write my own SegY reader, but then unfortunately discovered that something else, some other people have done that, because SegY is really a fantastic format. It's very, very old and with a lot of different versions around. So very glad that some others took that responsibility. But when I read it from Oxar, I use their API to read the seismic. So I could read one of them. They have a bit long names. Perhaps see if I'm able to copy paste that name. See if that works. At least it did not complain. I can also do the same here. Print C, and I will get information on the cube. Given the sizes and the things you need. And this is also a NumPy array. So I can show this cube, and yeah, it's demonstrated here. So yeah. So what I can do now, I can also, if I want just to export it to file, I can take out the SegY file from here. Some SegY. And if I need a format specification, it's kind of a FF format as file format. And that's supporting different formats for different data objects. So now it writes this. So now it's done. See if I can find this on disk. Yeah, so it was this some segue is written now. So yeah, and as I mentioned, if I want to take that in instead, I can just have XTGeo from file, and I can read this file I just have exported. So we have support for cubes, and what we can do now is something a bit more exciting, and that is I have this surface down here, so I want to slice this cube so I can grab the values in the cube and map them to that surface. So then I need to take in that surface again. Surface from Oxar project, and just call top Atlantis and depth surface. This looks right. Yeah, so it reads everything without complaining, so that's a good sign. And because if I do a slice operation, it will actually change this instance here, so I can make a copy of it, just call it S is X copy, and then I can do something like X slice cube, and I put in the cube object like this. And now I can write it back as X to Oxar project, and I just call it something dummy, and I put it on what we have the clipboard down there, so it's not as stored another place. Clipboard. So now I run this, and you see it's a bit small perhaps this, but now I generated a slice of this cube, and I can have some more seismic alike colors on this perhaps. Something like this. Yeah, so now it looks a bit more like seismic cube. And what I also can do now is that I can actually run it in a loop if I just want to have a slice that moves up and down. So for E in range, let's see, I take every meter. So I just want to do this one. I can need to make a copy every time. And I can add this I range here. So I add this. Change in. And then I slice it, and then I store it. See what happens now. So now see I make slice every 10 meter here. So it changed a bit. So that's kind of explains the interaction with, and this is something I've kind of worked a lot with, is that the different data objects should kind of be able to do things from one to another. So I can also, for instance, extract the surface from a 3D grid, or I can slice also a 3D grid with a surface and so on. So 3D grids has been one of the main focuses on this. I can give you a demo on here. So I will just drop this, and where did my Python go? It went. Just open a new one. Too many scripts here. So just have something called grid, and here I have a grid in the project, like here. See if I find it. I can take this one. Import XTGeo. A bit small. Large it. G is XTGeo grid from Oxar. I can read it from file also using a ROF format or a couple of grid Eclipse based format like eGrid or binary grid GRD ECL or ASCII GRD ECL. ROF is actually the fastest one. That's the kind of the Roxar open format for grids. But I just now take it from the project instead. So I need to, and this was called Geogrid _1. So I can read that grid into the memory here, and in the same manner as before, I can just print this and see what kind of main properties it has. Yeah. So it's not a big list here, but it can be extended actually. I decided this is a grid where there are approximately 650,000 cells. So, and I haven't showed you yet, but there is a documentation on Reader Docs here, where I have at least the API available, so you can go into, this is kind of what auto-generated from Python. We also have some examples, for instance, some examples for use in RMS. I have mentioned something called hybrid grid, which is at least a bit fancy because I can make the grid horizontal in part of it. And this is used in our troll model, which is a very large model. I can see if I'm able to do this here. So I can say G convert to hybrid, and I need to say how many divisions there are, and div equals to 10, for instance, and then I need to say top level equal to 1650, for instance, and bottom level equal to 1660. And then in order to see the result, I need to get it back to another instance. So I can take to Roxar, and I can have project, call it something else, hyb. See how this goes. And, normal. So now it made a new instance here called hyb. Just take off this one here, and I can show you a slice instead. Activate the cells. Yeah, so now you see it actually have got a horizontal grid in the middle here. So see, that was also quite fast because this is done mainly in the C code. Yeah. Another thing to mention also is that both for surfaces and for 3D grids, they can be shown as empty arrays, but you can also get the data frame. But before I proceed to that, I can also store this as to a file, and I can call it x.egrid format equal to egrid, which is the Eclipse egrid for format, and I can run this, and it will output the make this a bit bigger. See this file here. So this is just this file on Eclipse binary egrid for format. Yeah, and also said we can also present this as a data frame. So I can just say something df is g and data frame as a function, and I can print the pandas object. So there it comes. So it gives the cell indexes and the coordinates of that grid. And that is also possible to include properties here. So yeah, many likes to work with data frames. So the next thing I want to do is to perhaps I should dig some holes in this grid, or I can take another grid, or this original grid. So say that I have this grid here, and I want to inactivate or set values in some part of it. So what I can do now is that I can create a polygon, something called empty polygons here. Let's call them poly with big letters. Poly, and then I can digitize something. Yeah, it's a bit difficult to see. It's easy to see in the map view. I have it here. I can make it a bit more visual settings, and thickness 5. Yeah, so now you see the polygon here. And it was, yeah, so now what I can do now is that I can take this grid, which is still G, but I think I skipped this conversion to a hybrid. And I just take and read the polygons, which also can be read from file. Poly is equal to XTGeo polygons from Oxar project, and they're stored as poly as the name, no folder, and within the clipboard. See if this runs. It runs. So now the next thing I can do is I want to inactivate inside this polygon here. So I then can take G inactivate. That was wrong spell. Inactivate inside, and I just say inside poly like this, and then I can store the result. G to Oxar project, and I call it something holy case. And this took 3 seconds. So now I get this whole case. I can just take off this one here, so I'm not only visualizing the polygon. And I find the whole case, which was there. Now I got the 3D grid with a hole. I can show it in 3D also. There's a grid down there. Yeah. Or I can, instead of, I could have used the function set inside, where I can set the value, but that's only for grid properties, not for grid. So Inactivate is only for grid. Yeah. So I can then continue to another example. Yeah, and in this example, I want to actually take a polygon, and I want to try to make a vertical slice of the grid and plot it. Hope this works. So I can make I already have made something called fence. I can reuse perhaps. It's this pink line here. So I will go into the scripts again. Make a new one. Slice.py. Import XTGeo, and then G is equal to XTGeo grid from Oxar project, and I call it Geogrid 1. And then I take the polygon. Polygon. It's a bit boring with this editor in RMS. It does not allow IntelliSense, so I cannot just tab the words. I need to write them fully, but that's how it is. And the name of that polygon, did I say it was just fence? Yeah, fence. Start equal to clipboard. Like this. Polygons. Yeah. So now I can use a function called make random line. And I think I'll just copy a string here, so I don't need to write everything. So it's just grid, or I call it G, so I need to change that. Get random line. And then I can plot this if the opens works. Not like this, but like, no, I copy paste once more. Sorry, I just copy paste. Yeah, and since I use matplotlib, I need to import that. Matplotlib dot pplot as plt. So just make a small plot and I put it on disk because this I don't think this show will work inside RMS. I can call it something else for this demonstration. So demo. Yeah, I can also add that I just want to not to plot the grid. I want to plot the grid property. So I will need to put in a grid property here. Prop equal to XTGeo grid property from Oxar. And then I need to take this magic project again, the name of the grid, Geogrid 1. And I take this phi-t property in. So now I see if this works. Poly, I call it, I can call it poly here, perhaps. Like this. I can call it phi-t. Yeah. Yeah, so then run without complaints. So now I can see if I have this file here, demo this PNG, so I can just see if it looks like something real. Yeah, so now I actually made a plot of this. So you see it's a bit kind of bit mapped because it's sampling is just a regular sampling. It's not vectorized sampling, but at least this has been used on some fields just to auto-generate a lot of well fences and other fences when we run FMU. So you can make, since this is script and this can work from outside RMS, we can just batch it. So that's good. So the final demo I want to show you was a question on Slack earlier today. And that was to extract well data inside a grid. So then I go into this again and I make a new one. Well info, or what shall I call it, .py. Import XTGeo, that was very large. And then I can take in a grid again, as I did. XTGeo grid from Oxar project, Geogrid 1. And I take in the grid property also, so it's a bit more exciting. SP grid property from Oxar, and then the name of the property, which is phi-t in this case. Also big that it went away. And then I need a well. And the way I support wells in XTGeo is by just making data frames. So it's not the kind of very advanced data model for well. It's just to make a table with X, Y, Z and the logs. So similarly as the other, W equal well from Oxar, and it could also be from file. And I need to have a name of this 55 33 A4 we can take. Log names equal. I could just be a bit selective on the logs so I don't take every login. Now I can just print this data frame from this well, and I can see how it looks like. I forgot XTGeo here. Like this. So now it gets a data frame with the logs. Try to enlarge this a bit. So the next thing I want to do is that I want to get the grid properties, this porosity. I want to get this as an additional log. So what I can do then is that I say we for the well get grid properties. And if I go to the documentation here, you will see that this will read a grid properties data, which means I need to initialize a data object which has several properties within. I just call it GP, and I just initialize the class grid properties, and I could add the property that I had. I guess append props from the one I just read, which was this P, and I need to have it as a list. And the first I have here in this get grid properties is the grid properties itself, and then I need a grid instance. And now I will get an updated well, so I can now print this once more. See if this works. Yeah, so now you see I've made a new column called phi-t model over here. And so this is a sample, the 3D grid. I must admit sampling from a 3D grid is not a trivial thing, because the grid cells, they have 4 corners, and the 4 corners of space actually don't make a planar surface. So it's a bit kind of non-unique if a point is inside or outside a grid cell. So I think there's some number of remaining issues within the algorithm that kind of detects if a point is inside or not, but that is something that can be fixed. But I can now store this well to Oxar again, and I can take it as a new well if I want to project, and I can call something called new well. Yeah, I can just see if that works. So now I see it made a well down here, and I can see if this well is yeah. So here I have this phi-t model which I just made from the properties, and I compare it with the original phi-t. It did not come up. Why didn't it? Yeah, at least it's in the list here, but not. Yeah, there it is. It's a bit different some places, but that can be due to phases, or yeah. So that's not part of the investigation here, why it's different, but at least you have the possibility to compare it with the original well data. Yeah, so this was mainly my demonstration. So I can just conclude a bit now with a few slides. So just as told you, we use this library now as a kind of a lubrication or oil a bit on different parts there. So we use it inside RMS to help it a lot. We can derive seismic properties also between surfaces, not only from a surface, but as an interval. And we can use it after Eclipse and into other seismic operations, for instance, and also in what we call Webviss visualization. I can give you a quick demo on Webviss. So if I just copy paste this one and make it into a browser somewhere. So in Equinor, we have something called Webviss, which is also open source to visualize data through a well API, or not through a web API. So this is using a kind of a combination of server, Python on the server and JavaScript on the client. And in the background here is actually using XTGeo. So I can digitize a new fence here, and it will update the data in the top of here. So here's also XTGeo used kind of indirectly in the web surface, so in the web service. So this is a bit cool actually. So we're hoping to extend this also to, it works on quite nice on 3D cubes, but 3D grids is a bit too slow because searching for polygons in a 3D grid is something that could take some seconds unless there's a very smart algorithm on how to find the right cells. Yeah, so this was Webviss. So if I go back to the, so we just use XTGeo in many places now. So the current status is that it is active development, and we have currently consolidation focus. So it's not only me anymore doing programming here. So I've got a lot of help from professional Python programmers and C programmers, and we are doing consolidation. So we extend the testing and we find what you call corner cases in order to avoid bugs and improve both code and speed. So I can even mention that for 1 year ago, reading a ROF from the Troll grid, which is 160 million cells, took about 50 seconds to read. Now it's after one of these guys did a big improvement, it's actually down to 2 seconds. So reading a 3D grid in 2 seconds when it's 160 million cells is something we are a bit proud of. Yeah, so I think I'll stop there. So if there are any questions or comments, see if you have something.
Feel free to unmute anybody who has a question and shout. I had one around, do you have to work in the RMS window then? Or are you able to sort of run scripts in a completely separate environment outside? And as long as RMS is running with a port to connect to, the API will still work or not?
Just an example. So I just run it in RMS in order to have this visual demonstrated. But normally I actually run it in a VS Code. I think I can open a VS Code instance directly from here, and it will still be connected to RMS in this case. But in many cases, I just have a. This was Emacs, not VS Code, so I can run it outside also. And I think the majority of scripts are actually outside RMS, working on files directly.
Cool. And my other question was, when other people are using this, sort of your users, I guess in Equinor, and the users you're closest to, do they tend to do custom coding, or have you managed to sort of set up a set of standard base scripts that will work, and you have people who are just coming along and know that these are the scripts to execute to do a certain job?
Yes, we have some that are clever to set up code, but kind of most modelers are able to read code and do changes. But if they want to do something, they usually ask for help. But at first we set it up in a way, then if people just want to change the name of porosity from phi-t to something else, then it's easy. So, but there is a bit of a push that people, we kind of encourage people to at least understand code and be able to read code and do changes. And if they are more enthusiastic, we will be happy to have more that actually can do active coding also.
Cool.
Yeah, I really like this demo. It's really eye-opening. I mean, I don't use RMS for geomodeling. I mostly work in decision space and a little bit in Petrel. Are all the geomodelers at Equinor using RMS, or I'm curious if people are using some other software like Petrel specifically, and if XTGeo can work with exports from there, or I mean, it's really nice how you can go straight from the Rockstar back to your project. I wonder if anybody is using XTGeo with Petrel or Decision Space that you know.
Yeah, I have some kind of customers from exploration in Equinor who are more Petrel users. How exactly he's using it, I'm not sure, but I think when I checked Petrel some years or 2 years ago, it was kind of stick to what you call iron Python, which don't have NumPy and so on. So
yeah,
I haven't spent effort on that one, but I think that might have changed now. So, but I haven't tested it. But if they have an API, it could be possible to like I did with Roxara, to kind of make a window into that environment, right. Also, yeah. So, but I think this FMU workflow I talked about is very RMS oriented, because we were not able to use Petrel in an automatic way, and it's mostly on the Linux machines. So, but the idea with XTGeo to be kind of agnostic to everything. Yeah.
Yeah, great. Thanks for the demo.
Cool. Yeah, so Per Rolab was saying that he uses it completely outside of RMS, or runs the Python stuff from outside there anyway. But I did get right that if you have data in files, you can just step away from the proprietary package completely and just work.
Yeah, so
I just grids.
Yeah, so I just, if this grid was exported to file, I can just read it from a file instead and do exactly the same thing.
Yeah.
Yeah.
Cool.
So, and yeah, you mentioned SVGBlast from the past. Yes, perhaps. The reason was that the old Perl library was kind of connected to C through SVG, but I made something quite automatic, so I'm not doing much Swig adaptation. It's kind of more or less automatic every time I add a new C code, and I just use standard C. It's more or less automatic how it's included. So it works okay, but perhaps if I design it from bottom up today, perhaps I would use something else. But yeah, not the prioritization. It works nice, and it works quite fast with Swig.
Cool. Yeah, Mirone just in the chat there also saying that it works for the grid properties and results from Eclipse as well.
Yes, so we use it a lot on. We have something called. Perhaps. Yeah, we have something called. We have a wiki here. I can just show you. It shouldn't be FMU. So we are running this FMU, and we have a lot of, for instance, for seismic and so on, we can make average maps from Eclipse directly and compare them with the seismic, for instance. So I'm not sure if it's about these grids, but this one. So here's, you can get the mean of an ensemble, and this ensemble in this case could be just reading the Eclipse grids and make average porosities or properties and just output as a map. So it's not inside our RMS at all. It's just taking the output Eclipse files and read the properties from that and make maps and average properties.
Cool. Great. Perry, you put your camera on there. I don't know if you were about to chip in. Or not.
No, not really. I was just going to add to my comment on using it inside or outside, but discussing with Michael on Slack instead.
Okay, cool. Great. Well, if there's no further questions, so we can leave it there. Jan, thank you very much for the demo and the walkthrough and the live coding. It was good. It's great to see it in action. It's great to see Python and some tools being used, alongside the proprietary software and stuff to interact with them.
Yeah, that was really, really great to see. So hopefully I can figure out something to let me do the same thing.
Cool. And thanks again.